everyone. In this video, we are going to discuss in static calculus Cbt. So in question 4, we are required to estimate the forward price of a contingent claim that pays the inverse of the square of stock price at time 2 by Monte Carlo simulation. We will be using the inversion method to do the simulation with the given 150 uniform random variables. So the question has also provided us some of the important information to perform such calculation. So firstly, the time t price of the stock is ST. The current stock price is 2. The volatility of the stock is 13%. The dividend yield is 3.5%, and the continuously compounded expected rate of stock price appreciation is 20%. The Sharpe ratio of the stock is 0.75. So the given information was summarized in this table. So apparently you could see from here is S, which represents the initial stock price, the current stock price. Standard deviation delta refers to the dividend yield. Alpha minus delta refers to the continuous compounded expected rate of stock price appreciation. So to get alpha, we just need to add the rate, the rate of stock price appreciation with the dividend yield, and we will get the alpha. So for the Sharpe ratio, we are going to use the formula of Sharpe ratio, which is alpha minus R divided by ST, which is the standard deviation, to get the risk-free interest rate represented by R. So by using some basic calculation, we would get the risk-free interest rate is 0.1375, which is 13.75%. After having all of these important information, we will then proceed to calculate, to simulate the Z value from the given X, which is the 150 given uniform random variables. So for the Z, we will just use the standard normal distribution, and we will be using the norm standard inversion function in Excel to get the Z value, and after getting the Z value, we will then need to find the expected payoff at time 2. This because the Monte Carlo price estimate equals to the expected payoff at time t, and after getting time t discounted back to time 0. To get this expected value, is because we will be using this formula, is because it's mentioned that the forward price of a contingent claim the contingent claims that would pay the inverse of square of stock price at time 2. So we will then proceed to calculate the inverse of square of stock at time 2. So this will be 1 over S squared 2. So S to the power of -2, because is the inverse of time 2, so is power -2 times with the exponential to the -2. This -2 is the power of S as well. Bracket R minus delta minus 0.5 standard deviation squared times with 2 plus this 2 here would be the time t. So time t will be 2 plus standard deviation square root t. So we would be having square root 2 as well, times with Z. The Z value refers to the value we found here using standard normal inversion. So by applying this by applying this formula, we will be getting this payoff easily. All of the payoff was calculated successfully, and after that, we will be finding the mean of the payoff. So the mean of the payoff is very easy to find. We just need to use the average function in Excel, and we'll sum all of these expected payoff together, and we will be getting the mean of the payoff. After getting the mean of the payoff, we will just discount it back to time 0 from time 2. So to do this, we just need to times the mean of the payoff with exponential to the power negative r, which is 0.1375, times with our t, which is 2, and we will be getting the Monte Carlo price estimate. And we will be getting the answer of the forward price of a contingent claim that pays the inverse of the square of stock price at time 2 by Monte Carlo estimate would be 0.138017. Thank you.